Okay.
Sure.
Before we jump into the topic of the day, and I know you're impatient to hear from our guest today, just a quick words about Vega. For those who are not familiar with the breadth of our services. So Vega aims at building the bridge between science and IT, and as a matter of fact, all the employees of Vega have dual skills, science and informatics. Our goal is to help our customers in setting up systems which aims at improving their operational efficiency and foster innovation. We specialize in life science, where we deliver 360-degree services, thanks to our core pillars: lab and research, clinical development, informatics solution, and QA. Upcoming events where you can meet us again in person: ICSV in October. Also in October, yet another Vega breakfast with colleagues, and in November, Utah Analytics Day in Germany. But let's now jump into the topic that will be presented by the Swiss Biobanking platform, with whom we've been working for many years already, to our greatest pleasure, and I'm sure it's shared. You'll confirm. And so the speakers today, Christine unfortunately cannot join. She had a small accident this morning, but Sabine will take over what Christine was planning to present. As you can see on the screen, Christine is the Executive Director of the Swiss Biobanking platform, which will be presented today. She holds a PhD in virology, which she did in 2004, obtained a master in health management, and entered into biobanking, into the biobanking field, something like almost 20 years ago. Her experience is mainly as a reference in the development of state-of-the-art biobanks, first in oncology, then as a centralized institutional biobank in a hospital setting in 2013. In the biobanking field, she implemented the first general consent for research purposes in Switzerland, and she has always been interested in biobanks sustainability. In 2015, she took the position of Executive Director of the National Coordination Platform in Switzerland for biobanking activities, which is called the Swiss Biobanking Platform, with the vision to promote access and usage of the existing and future bank biospecimens for research purposes in the human and the non-human fields. Sabine, who is here today, is a biologist by training. Scientific background from more than 10 years in clinical and academic research, graduated in PhD in biology in the field of diabetes from the University of Geneva, first being appointed as postdoc at the Broad Institute of Harvard and the MIT in Cambridge. She was involved in both clinical and academic research settings on projects related to psychiatric disorders. Then back to Switzerland. She transitioned to clinical research, gained a master in management of clinical trials, and she joined in 2016 the Swiss Biobanking platform. Now Khalil, where she acts as a Chief Scientific Officer. Last but not least, Khalil, the designer and researcher from Lausanne. After having had the Master of Arts in Interaction Design in Geneva in 2013, he worked as the researcher in human-computer interactions at the University of Helsinki, where he stayed for 6 years. He was focusing on the design, prototyping, evaluation of digital tools in support of information exploration. His work led to several peer-reviewed papers in published journals. and he created, which was the basis for his PhD thesis. Then I'm going, you can read like me, so I'm going to go straight. Today, Khalil is working for the Swiss Biobanking platform, where he applies his visualization and interaction technique skills to develop some of the things you're going to see today. Now, let's leave the scene to our guest. Thank you very much for accepting, and then I let you share your screen. Sabine, Khalil?
Yes.
Yes. While Sabine is preparing, I think you prefer to have the questions at the end, go through the presentation and have the questions at the end, correct?
Yes.
Now, everybody can put questions in the chat during the presentation. We'll go through it after.
So thank you, Daniel, for your kind introduction and this opportunity to present our SBP BIMS project to this Vega breakfast meeting today. So in introduction, I will present briefly a few slides regarding SBP, then the introduction of the SBP BIMS project, and I will hand over at Khalil, who will guide you through the demo of our tool. So Swiss Biobanking platform is the national research infrastructure supporting human but also non-human biobanking in Switzerland. We are an independent association funded by the Swiss National Science Foundations, whose founding members are from the 5 university hospitals. The governing board is composed of ordinary members from these 5 university hospitals and from expert members with expertise in liquid tissue biobanking, but also non-human biobanking, including veterinary microbiology and natural history museum. Our mission is the coordination and the harmonization at national level of biobanking activities in order to increase the overall quality of biobanking, increase access, and the visibility of biobank sample collections and the interoperability of biobanks within our network. Our positioning is to serve biobanks from our network, of course, but also biobank infrastructures, the organized facilities that offer services to biobanks, and researchers. From the Swiss landscape, we do interact with many organizations, including institutions hosting the biobanks, research funding organizations, regulatory and policy makers, and at the European level, other networks, also at the national levels, other important research infrastructures. SBP strategy relies on 5 pillars. 1 pillar is on quality, visibility, interoperability, and we have added recently 2 other pillars, one on education and one on sustainability of biobanks. So I would like to present the operational teams working to implement all the objectives from the service level agreement we have in place with the Swiss National Science Foundation and with Christine as the executive director. And it's my pleasure today to present our SBP BIMS project that we have developed in collaboration with DData and which support the interoperability pillar. And this development integrates SBP datasets to support the documentation of sample-related data, but also SBP sample modules that will be presented to you by Khalil later today to facilitate the daily operations of biobank and facilitate the proper management of samples and data. So why do we have introduced and developed this important development? So as I mentioned in the introduction, SBP is the national research infrastructures to monitor, coordinate national biobanking activities. And we do serve biobanks from our network with different tools and services that we have developed to support quality, interoperability, and access and visibility. Among the tools that we have developed, we have the Biobank Scan, which is our monitoring and evaluation tools to evaluate biobanks practices and to support our SBP label strategy. And then compliant biobanks in terms of governance and operational management can then become visible in SBP Next, which is our tool to promote the visibility in our network. SBP Next has two functions. One directory functions to increase the visibility of biobanks in our network, but also one sample exchange platform to connect biobanks with researchers. And at this stage, the biobanks has also the possibility to appear in BBMRI directory to increase their visibility at the European level. And our current activity regarding IT development is the SBP SMPL, which is part of a bigger project, SBP BIMS development to support interoperability. So why do we have started this important development? It was to fill the gap and provide a missing link in SBP strategy, but also to respond to an important and ever-growing needs from biobanks from our network for better documentation and traceability of their samples and data for research. To do so, they require to use dedicated systems to be compliant with the security requirements, but also in terms of traceability, which is one of the major legal requirements. And they need such systems that can evolve over time to be able to be adapted to their future needs. However, deploying such professional system is complex, time-consuming, and expensive. And a large majority of biobanks are using Office software such as Excel because they are easy to implement and cost-friendly. However, we all know that these solutions are inefficient in terms of data entry. They are limited in terms of interoperability. They are not providing the environment to comply with the security and ethical and legal requirements. And of course, they are not future-proof. However, to make the biobanks eager to switch to a professional systems, we need to solve these challenges, but also to sustain these easiness in terms of implementation and the cost friendliness of the solution we want to provide. And this is our goal, to provide such a professional and compliant system, especially for biobanks working with Office software and Excel. So we need to provide a solution which is cost-friendly, which will minimize the time and the resources for configuration and customization, which will implement and integrate international standards to promote interoperability among biobanks, propose a compliant environment and be user-friendly to be fully adopted by the biobanks and be easily integrated with other existing systems. And this is what has been initiated with a new concept of SBP BIMS to define a common basis for biobanks practice harmonization and information, but not only. The solution we want to propose to our biobanks from our network is affordable, should be affordable, even for smaller biobanks to fully adopt the system and move away from working with systems such as Excel, be adaptive. And we have worked with wide variety of biobank use cases, from veterinary, microbiology to human biobank use cases to be able to provide solutions for different environments. We have integrated SBP datasets to support the recording of sample-related data and promote the interoperability of our systems. And this system will be able to be connected with other systems, including SBP Sample Electronic Catalog or SBP Next. And the systems will benefit from the secured environment as provided by the data, the BIMS provider that has been selected by SBP to provide the secure IT environment and be able to comply with the traceability requirement. So indeed, we have selected data during a public tender as our BIMS provider. And we have integrated SBP datasets on top within the DData environment to ensure the documentation of sample-related data and promote interoperability, but also data quality. And we have also developed 2 plugins to be integrated within this DData environment to facilitate the operation, the daily management of samples. And you really need these 3 components to speak about the full package of SBP BIMS. And just a few words regarding SBP datasets for those who are not aware of this development, and this is an important development in this project. SBP datasets were published a few years ago and were developed by SBP working groups composed by national experts in multiple areas of biobanking, including veterinary, microbiology, human liquid and human tissue experts. They've been used as the data model for these BIMS after having been slightly adapted to the requirement of the SMPL modules. They rely on the SENS specification from the European Commission on Normalization and the related ISO standard on biobanking. They rely on the SPREC for standard pre-analytical code from ISBER and from MyAbyss from BBMRI. So they list all the pre-analytical variables that need to be documented when you characterize a sample stored in a biobank. Those are the core data sets. Then if you want to record more variables but related to the quality of these samples, those are the extended data sets. And depending on the biobank's practice, the biobanks may want to add additional variables that are relevant to their activities. And those are the biobank-specific data sets. From an architecture point of view, we have 2 options. We offer 2 options. The preferred one is the BIMS, being hosted on a local instance within the institutions to benefit from the IT secured environment as provided by the institutions. Or for biobanks working without sensitive data, they can use the cloud-based solution proposed by SBP. And in this case, the BIMS will be hosted in a remote server at the University of Lausanne. So here you can see the 2 plugins, the 2 modules, SBP samples that we have developed and that are integrated within the DData interface. As mentioned in the previous slides, DData will be offered to provide all the different set of modules as different BIMs can provide. You can manage roles, you can manage users, you can use the data view of the data or their storage module, as well as to link a piece of equipment such as printers. And Khalil will present to you these 2 modules, one which will be able to support the biobanks at the configuration level, and the other module will be for the sample management and the day-to-day operations. So regarding the way forward, we have launched a call for biobanks, and we are still in the pilot phase. We have 3 pilots managed by SBP, 1 veterinary biobank, 1 microbiology biobank, and 1 human liquid biobanks. 5 other pilots are managed by the CHUV with the support of SBP. These pilots are part of a project at institutional level, which is called Horus Biobank Project, which tests the integration of such solutions with other institutional systems, such as a consent system or data warehouse. And our first pilot will be live next week. So this is a great achievement. And we will be able to propose the solution to other customers at the beginning of next year. So in the meantime, we will continue development, improvement, and support with our pilots. So just my last slide of this introduction before handing over at Khalil is to present the team which is working on this BIMS project. Mark and myself to coordinate the activities around the pilot phase at the moment and later on with the new customers. Then Khalil, who has designed and developed these two modules that will be presented to you in a moment. Flavien and Lou, who are the two biobank specialists supporting biobanks in the definition of their needs and the implementation and the translation of these needs into the sample models. And Louise, who is our UX UI designer, and she is responsible to the training aspects, and Raphael, our IT solution architect. And from the data, we have Aline, the focal point and the project manager from the data side. So I will
Thank you.
leave Khalil present you the two modules now.
Yes, I will just start with a couple of words about the design of those modules. In other words, what we were trying to do is to create a one-size-fits-all information management system for biobanks, and something that works out of the box for any biobank and every biobank. And the challenge is that every biobank has a very unique way of doing things, a very unique protocol, and to understand or to find how to address all these needs, we had to analyze a lot of protocols and ways of working from many different biobanks. And what we've noticed is that, yes, every protocol is unique, but each one can be understood as a sequence of operations or operational events, like collection, transport, centrifugation, aliquoting. All these are operational events that are really things that you do in the physical world, and each one of these event is actually pretty standard. For example, there is not 1,000 way to characterize centrifugation. You have the start time, the force, the temperature, the duration, the break or no break, and that's basically it. So every protocol can be, every sample life cycle can be understood as a sequence of very standard events, each event being the generator of a certain amount of fields or values to be documented. And all parameters required for sample characterization can be matched to such an event. And all this creates an opportunity. It offers the opportunity to understand those operational events as building blocks, something that offers a visual way to build and transcribe protocols, and that really matches the data with the operational reality of the field or in the lab. And it also the opportunity for a structure like SBP to embed the standards and the data sets that we have published within the system that we are promoting and providing. I think I can now switch to the demo itself. What I will do during this demonstration, I will start by using the sample configuration module to show you how quickly I can represent biobanking protocol within the system. And then I will use that freshly designed protocol or workflow to collect imaginary samples so that you have the full cycle, use cycle of the system. Here I am in the workflow that is called demo test that I have already created, which is completely empty. And you start from that subject, and from that subject, we start by defining which sample you would like to collect from that subject. So let me click on that little plus, and let's say I will collect whole blood for serum. I will collect one container at a time, a little suffix so that I can identify it in the sample IDs. I will call that WB for whole blood. Let me select a generator for IDs. That's what will construct the ID of the sample. I will set a little color for the sample. Sample type, let me select whole blood here. I will collect it in an EDTA tube, and I will want 5 milliliters. Let me click on submit. And now you see there is one sample line that has been created, whole blood for serum. And you can see that every sample line that is created starts with container creation. That is basically the selection of an empty container. That's when the sample starts its life cycle, an empty container, which then is filled during the collection event. It's filled from the subject with whole blood in our case. Then I will click on that little plus to add steps to that life cycle. So let me click on that little plus. I will select a type for that event. So that's what I was referring to, operational events. I have here a small selection of events. And here I will typically select a reception, since usually that's when we have the step where the sample is collected, then brought to the laboratory. This step will set the sample to the status received, and I click on submit, and immediately you can see that there is one more step in my sample lifecycle, reception, after which I will add processing event, which will be centrifugation, and it will set the sample in the status in processing. You can see there is a little file that appears next to the step. This is the form that will open when you collect samples that will prompt you to inform the data for the reception or the centrifugation. Let me click on the centrifugation one. And you can see that by default, the start time will be today date. It will be the time at the moment you answer the form, done by, there is a little asterisk, this is mandatory, and the temperature. Let's say I will perform the centrifugation at room temperature. I can specify default values for the force, the duration, breaking or no break. Let me set those default values. I will set a static value at 5,000 Gs. The duration, let's say the protocol asks for 10 minutes at 5,000 Gs, and breaking static value, and we will put no breaking. Let's disregard the post temperature value. Here I have specified the form that I will have to fill when I perform the centrifugation. After that centrifugation, the sample will be ready for aliquoting. So here I select a derivation, and I will call it aliquoting. And after which the mother sample will be discarded because empty. So here I have the full life cycle of my specimen, from the container creation to the aliquoting, after which it will be discarded because empty. And that aliquoting will yield new samples, derivatives in this case. So I can click on that little plus here. And I will call that new sample serum. Let's say I will create 3 samples from that aliquoting process. Let me put a little SE to specify serum in the sample ID. Here, derivative. Let me put a little yellow here, and I can select in the sample type serum. Select the container type, 1.5 milliliters. There. And now you can see there is a second sample line, which is the life cycle of my aliquots, my derivative. Content creation, content allocation, and let's not do a lot of things with that. Let's put it directly into storage. I should find it here, storage, and I will call it long term minus 80 degrees. And the sample status will be set to in storage. I click on submit, and here I have a small but complete protocol where I collect whole blood from the subject, I process it, I aliquot it, and I store it. And this is a very basic but functional workflow. And what I can do now is switch to the operational view, which is very much the same, but the same looking, but it looks very much, it allows me to collect samples. Here you can see I can start collecting sample. There is no subject selected, no case selected, because no subject has been registered yet. So what it will do, if I click on collection, it will start by prompting me to create a new subject. Here, P001, that sample, that ID is automatically constructed. It's something that can be completely customized by the user. Here, that's how it builds it, with a P for participant and 001 because it's the first one. Let me assign some data to it. Okay, let's say it's very young. And submit. So my first subject is created. Now a new case, that's basically the visit. It's done by myself. Let's specify a day. Let's set it at today, and the ID is also automatically constructed with the name of the ID of the participant, followed by C01, which means first visit of that participant. I click on submit. And then you have that form, which creates also an ID. The collection is done by myself. The time is, here there's a little error, but I specified the time at now. I can specify the collection institution, department, service. All those values can be specified by default. Let's disregard them for now. But you can see at the bottom, it will ask for the samples to be created, and the only sample that I'm collecting is whole blood for serum, and the default quantity was 1. So let me click on submit. And you can see that one sample has now been created. It shows me a little table that summarizes everything that has been done. You can see the sample ID here, P001, C01, whole blood 1 has been collected. You can see the sample type, the content volume, the subject, the case. So all the filiation, all the data, I can check it here and close that window. You can see that sample has appeared here, and it appears at the right position within the sample life cycle. The container has been selected, the collection has been done, and that sample is now in the status collected on here. Let me directly start a new collection with another subject. I will do it very quickly. Let's select a date done by myself yesterday. and again today, and let me create another sample. So I just did the same, but this time the subject is P002, and here you can see there is only one sample selected because subject P002 is selected. If I select all subjects, I can see now the two samples that have been created and that are coming from two different participants. Now I can click on reception to make those two samples go to the next phase of the life cycle. So I click on reception, start time, it's now, that's right, and done by myself. Submit, and you can see both samples just went one step further in the life cycle. I can then centrifuge both samples. And you can see that when I click on centrifugation, if the two samples are selected, it batches them. I can centrifuge them all at the same time. And you can see that all the values that I entered previously, the temperature, the force, the duration, they are all here because I've set them as value by default values. I click on submit, and now those two samples are next in line. If I click on those two samples, I can have the summary of the samples and all the data that has been collected, their content, the subject, the case, etc. And I can now aliquot them again in a batch, now by myself at room temperature, and I will create from them serum in quantity 3. That's what the protocol is specifying. And when I click on submit, you can see those two samples have now been aliquoted and they disappeared because they are discarded. They are, of course, still in the data, but they are not appearing anymore on the workflow. And I have now a summary of all 6 samples that have been created, the 3 derivatives from sample 1 and the 3 derivatives from sample 2, and you can see the consistent IDs that have been created from there, and they all contain 1.5 milliliters. If I was doing the aliquoting, and for one aliquot I wasn't able to put 1.5 milliliters, but let's say only 1 milliliter, that's something that I can correct right now. And I select all of them, save selection, and I can put them in storage. Yeah, that's basically how you work on that. If I go back to the configuration module, I just wanted to show you how you can add, let's say, we can take a skin biopsy, for example. I want to show you how the workflow looks like when you add more samples to it, when you make it more complex. Like so, you can see I have added a skin biopsy here. I can add quickly a little storage step. I can add here a new branch so that the aliquoting, I not only take the plasma, but I could be taking the red blood cells. Just to show you how a workflow can become more complex and very, very complete. And among the pilots we are working with, some are very complex and are taking up to 7 samples per subject in one collection. And each of these samples is derivated in 2 or 3 aliquots, so that workflow can become very very hairy, very complex. And as you've seen in the operational view, you can focus on only the collection part, or you can show the branches and show all the derivatives, so that you can have access to everything. One of the benefits of that view is not only that you know where you are in the workflow and what you are doing, it's really a mirror of the operational reality in the lab, but it also, for biobank administrator, it provides a very precise overview of the state of your biobank at the moment. You can see if some samples have just been received, if something has to be done. It's something that is very clear, and progressively you get a very complex but very legible overview of all the samples that have been collected, that have to be worked with, etc. Do I forget something, Sabine? No. Yeah, I think I'm done with the demonstration of the tool. Did you want to?
No, we can move.
I think we're done with the presentation, and we'd be happy to answer questions. Est-ce que je mets comme...
So, hello, I'm Modest Korf from Aliferon AG. We are doing usually cheminformatic. We are in principle the data warrior people, a data visualization tool for cheminformatics, but also for biological data. The tool is used by around 90,000 people at the moment. It is open source, and we are building functionality on the top of it, connecting it to databases. But yeah, thanks a lot. Pardon?
No, go ahead.
Thanks a lot for your presentation. It's great. It looks like a great tool. I have a question, quite a simple question. When you describe your sample at the beginning, can you also enter the species of the because I mean, if you have a human, and if you can enter the species, and then maybe a little bit more fine granulated the strain, which is of course also quite important.
Yes, thank you for your question. That tool has been designed from scratch to address multiple environments for samples. So we are addressing humans, veterinary, microbiology, and even plants. So the nature of the subjects can change completely. It can be an ecosystem, it can be a different species, and yes, you can specify basically everything. So we are working with a veterinary biobank as a pilot, and they have very specific fields regarding the species, the coat color of the animal, and things like that. And we could really challenge the fact that you can really customize the data set that you are using, and all the fields, specific fields that are really necessary for your specific biobank.
Follow-up question, okay.
Go ahead. I don't see any question, yes.
Okay, thank you. This is already quite good, but then of course, if you do sampling in, I don't know, hospital environment, for example, and so on, and of course it is quite interesting in the areas of oncology, you have now sequencing data often connected to your sample already. Can you also link it then to the sequencing data? Is that possible?
Yes. So possibility for linking data from that tool to external tools was highly important, because Swiss Biobanking platform doesn't recommend to store clinical data and personal subject data within that tool and to keep those data separated. So all the linking possibilities are really central in the solution that we are proposing. Also, we are not in the that tool is not really in the business of storing, managing really very heavy files. So yes, the linking to data analysis and sequencing results, yes, it's baked in.
Okay, thank you. Cool.
Thank you.
I don't see any question in the chat, but is there anyone from the people connected on Teams? Is there anyone having a question? Yes, Riyad.
I would like maybe just to complete on the questions reported by Modest. So the tool you have seen is dedicated tool for biobanking, which is really building the workflows and so on. But it's incorporated in a tool behind, which is the data that has its own modules. For example, in here we didn't see how to store samples, like the freezers view, and all of that is part of the system. So they can just change module and show you how it is, and it's completely seamless. And the part about NGS, for example, is also integrated, so you can have the data files for instruments, and you have also specific protocols for and workflows for NGS. So we just purely focus on the biobanking part, but there are other sections, and the tool is very flexible to build also any plugins on top of it.
Yeah. I think that what was Khalil mentioning is quite important, that you can also hide the sequencing data because of data privacy reasons. Yes, because for an animal it's no issue, but if you have patient data, it becomes quite sensitive. So I think the part that you can hide the connection is quite important. That not everybody has access to us who has access to the biobank. Yes.
Yeah.
Yes.
I see someone raising his hand, RB. I don't know what's the name behind RB.
Yes, hello, this is Raja. I just have a question. First of all, congratulations. This is really a great system. I really like the flexibility of creating processes. I'm just wondering, in case a biobank wants to use that system and they have a big repository already there, what would be the best approach to migrate all this data under this system?
So we are already in this case working with those pilots. We are already in the process of importing legacy data. Since we are working mostly with biobanks who were doing things the best they could using Excel spreadsheets and things like that, it's often a messy process, but using scripts and basic import tools, we manage to import those. So the importing legacy data will necessarily require some custom development. It's something that you can easily do if you have any small IT infrastructure or someone within your organization, or something that we can help you with. But yeah, it's always a process that we should not underestimate. It always takes some time.
And this is also a service proposed by DData and the legacy data import. So you can also refer to DData, and they have this expertise, and they are doing this as a mini project for you if you need it.
Great, thank you.
Yes,
I would just add on.
you want to add on that one? Because there was another question.
Yeah.
But just before, does it answer your question, Raja?
Yes, definitely, thank you.
Yeah, I just wanted to add on that one. So indeed, the data migration can be quite challenging. And in that regard, in most cases, we do it through Excel imports. And it can be very, very powerful. As an example, the Latvian Biobank has migrated all their data, which is almost 500,000 or around 400,000, through Excel. I mean, they exported the data to Excel. We imported back, and they could see like the errors, and they could easily fix any issues. So even for very large data, it's not an issue.
Great, thank you.
We have a question in the chat in terms of interoperability. Which other data management systems can it communicate with? For instance, systems that manage clinical trial and research data. And then there will be, I don't know if it's one. Did you get the question, or shall I repeat? The question is, which other data management systems can be connected to what we've seen today, and examples given are clinical trial management, trial systems and research data systems.
All right. The answer is really any which one. We are working already with pilots who are already interfacing with REDCap. But yeah, basically we have chosen the data at the end of a lengthy selection process because the data is extremely powerful and flexible. Because of that, by itself, it is a quite complex tool to use. So for that, you have either the data team that can develop things to your specific needs, or we have developed that sample layer to help most biobank be autonomous on day one using that system. But the data makes it very trivial to interface any system with any API, any external system, and it works. Yeah, it's very trivial to do. But right now we had an example of interfacing with REDCap, for example.
The second question is, I think you already have the case. How friendly is the system when you are in low resource settings? Yes, in the biobank, having not so many people to configure, or and then the question then relates to the cost of acquisition and maintenance.
So regarding there is one cost, several costs that we try to get rid of through our system. The fact that it should work out of the box for most biobanks in simple settings. Of course, if you have very large needs and specific needs, you can develop many things that will, of course, add up to the customization and to the final cost. But by using that system, you save on training time, you save on specific custom development time, and this is all very significant. Now, Sabine, I don't know if you want to add something regarding the overall cost.
Yes, just to add first to this question. So it is designed to be easily configurable by non-IT specialists. So the cost in terms of customization, when you need to go back to each BIMS provider, is very expensive. So in that regard, this solution should prevent to go back to the BIMS provider and has highly intensive costs regarding customization. And then for the cost in general, we have the one-time costs that are related to the business analysis to understand your needs, for the setup, the small configuration of your workflow at the beginning. But then you have the license fee, the yearly license fee in collaboration with the data. So it's a business model that we are setting in with the data now.
Does it answer the question? Okay, any more questions?
If there's already a question, I have one. I'm afraid a bit nerdy one, but it's an ongoing discussion. When you mentioned how you create your ID, it is an explanatory ID, yes, and there's an ongoing discussion how whether an explanatory ID makes sense or a totally artificial ID makes sense. And if you create the ID from the process, yes, from the workflow you're creating, because you're deriving it from how the final sample was created. So can it be the case that you end up with a very long ID, because if you have several derivatives, or that you then at one point cut your ID again?
So the ID generation is something that has I have not demonstrated in detail. There is a little syntax that you can create and that you can attribute to. You can create as many ID generator as you want, and that syntax can be specific to any type of sample that you create. So there is no automatic how do you say, concatenation after each ID. It can really be as you want. You can, at some point if you extract DNA, for example, you can go back to just having the participant ID and putting DNA afterwards, or things like that. But the ID, you basically do what you want with it. You are really free to design that ID any way you want.
Okay.
And you can add additional IDs if you have an external barcode, or that's the system ID, but you can have other identifiers for the sample configured during the process, correct, Khalil?
That's right, yeah.
I have maybe a question. I'm David, I'm working in lab automation, and I see the data of DLIMS was already made for biobanks, and you made it more specific for our case in Switzerland. And I'm kind of, maybe you can comment on how much work this was, because for me it looks like it was already quite specific for biobanks, but now it's even more specific. But it should not be too specific because you want it for whole Switzerland. But I guess biobanks in the US or in other European places are very similar to our biobanks here. So I was just wondering if you could comment on what was the reason to make such a specific Swiss solution.
It's
I can comment.
Only to be careful. I'm sorry?
I can comment for you if you want, Khalil.
Let me try first, and then you can compliment if you want. It's basically just a way to be careful, because the biobanks, the biobanking workflow that we have analyzed come from our network of Swiss biobanks. So we just cannot take a risk and say that it will fit everyone. We have based our experience and challenged our proposition through Swiss biobanking workflows. That's basically it. Of course, we have the secret ambition of having developed a tool that would fit most biobank in Europe and possibly the world. So yes, that's basically it. And regarding the specificity of the workflow, the specificity of the level of specificity of what we have developed. Again, the data was selected because it's extremely powerful, extremely flexible, and extremely consistent. You can do whatever you want, and the proof is that we have developed our module entirely based on the data as a platform. So it's an extremely powerful tool, but it can be overwhelming for a small structure who would access it from scratch, and it would require that small structure to collaborate a lot with the data team to have something that is up and running. And we were trying to create that layer that will make it much more user-friendly from the start with a small biobank that doesn't have necessarily a huge IT infrastructure or things like that. Correct me if I'm saying something that Riyad, if you want to complement on that. But yes, that's basically it. And regarding the amount of work, we've been working on that for around 2 years now, regarding the design, the conceptualization of the tool and its implementation.
Thank you. Just to add on that, indeed the solution was made for Biobanks from the very beginning. But then it's more global LIMS, so it can be used, for example, environmental testing. That we have, for example, CERN using it for that. So when you implement it in the beginning, you don't have necessarily the wordings of Biobank, so you don't have the step collection. So you have to create it. However, what was made by SBP, as you could see, it was all out of the box. So the steps only for Biobanks, and what you didn't see is all the complexity behind, because there is the structure that was created, like all the relations, and having something very complex but very simple from the interface. That was the goal of Swiss Biobanking platform. And any biobank will be able to implement it out of the box and still have all the, and I believe the data set behind is very, very important aspect that is added out of the box, and all biobanks will automatically be standardized and have the fair structure to easily share data and out of the box. So they don't need to customize that. They don't need to think about that. The system will guide them through that.
Yeah,
exactly. This is what I wanted just to add on top of what you are saying here. It's this visual interface, which is really the front end that will facilitate the daily operations of biobanks, because it's really intuitive how it works, even for non-IT specialists. And then the other added value is this integration of SBP data sets in the different forms the biobank will fill in the conduct of its different activities. So they are guided for the proper documentation of sample-related data. They will gain in interoperability, but also in terms of data quality as well.
And yes.
No,
Go
just
ahead,
to
Daniel.
answer the original question, is it really meant for Swiss biobanks? Maybe let's reset the scene. data is a LIMS, on top of which SBP has built 2 modules that will facilitate the biobanking processes. They inspired themselves from the Swiss biobanks. But if you look at the way it's constructed, it's made of small blocks which are common everywhere in the world. Everywhere in the world, you do a collection. Everywhere in the world, you do. There are shipments. Everywhere in the world, you do something. So the steps are not typical to what happens in Switzerland. They are all the same. So if you want to apply exactly the same thing to any biobank process, you can anywhere. Now, the modules for now, they are a bit more reserved for the Swiss biobanks, but I think it's the idea to open it more widely. I don't know if it clarifies the question.
Yeah, no, perfect.
So it's not specific for Switzerland, it's biobanking processes.
Yeah.
Sorry, Khalil, you wanted to say something?
I just wanted to comment on something that Riyad said about the complexity of the data that is being generated behind. That's something that the data allowed us to do, is to have data stored in graph. That means that the filiation between a subject, a case, a sample that is collected from the subject, a derivative, all that are dynamic links. So if you update the status of a subject with some analysis or some results that come back from the DNA sequencing or things like that, all the derivatives and all the data that stems from that subject will be live updated. It's extremely useful and exhaustive as a way to store data.
Any other question? Okay, I guess we're gonna close the session. Well, we've been at Vega very pleased to accompany you in that journey. Well, it's not over, but there's a big milestone next week, I heard, with the pilot going live.
Yep.
We wish you all the best, and all the best for the future pilots, but also rollouts. Thank you again.
Thank you, and thank you, Vega, for the crucial help that you have brought to the project at a very important time. Thank you.
Thank you very much. Good.
Thank you.
Let's close the session then. I officially declare the session closed.
Thank you.
See you. Bye.
Bye-bye.
Bye-bye.